Have you ever wondered why when you're going up in an elevator you feel heavier? Then when you're going down you feel lighter? Well, Isaac Newton wondered the same thing. And now to get to the bottom of it, we're going to look at his second law.
Newton's second law says that the net force on an object is equal to its mass times its acceleration. This means that if the forces on this recycling bin are unbalanced, it will begin to accelerate. All this information can be organized in a free body diagram. If you want to learn more about free body diagrams, check out this video by Joanne. The apparent weight an object feels is the force acting upwards on it. This is what a scale measures. Contrary to popular belief, it does not measure the force of gravity. As you can see, as I push on the whiteboard eraser, I increase the force acting upwards, and so the number on the scale increases. If you're standing in a stationary elevator, that is, your velocity is 0, then we have the force of gravity acting down, and the force from the elevator floor acting upward. These forces add and cancel out to give you a net force of 0 and an acceleration of 0. In this case, your weight would feel normal. If you were in the same elevator now moving up, that is, your velocity is greater than 0, then we still have gravity acting down. Now we have a larger force acting upward. These forces add, giving a net force upward, causing you to accelerate upward. Since the upward force is greater, we now feel heavier. In fact, if you were to stand on a scale in this elevator, you could watch as the needle would begin to rise. Now, if we were in the same elevator moving down, that is, your velocity is less than 0, then we still have gravity acting down, and we have a smaller upward force. These two forces add to give a net force down, causing you to accelerate down. Because the upward force is smaller, we feel lighter. If you were to stand on a scale in this elevator, you could watch as the needle would begin to fall. An object in free fall has no apparent weight. Let's take a closer look at this. As the chalkboard eraser falls, it has only the force of gravity acting downward on it, but no force acting upwards. Therefore, it would appear weightless. You can think of this like astronauts floating around in space with no apparent weight.
Okay, so we got Newton's second law, mass, apparent weight, free fall. These are all really nice concepts, but one thing's for sure. If you want to lose weight, or at least feel like you're losing weight, just take a trip down an elevator.